Welcome. As we continue taking a look at simple interest, we want to consider a relatively simple application here. So let's say David plans to cover the costs for his recently born child for college. It doesn't specify that here. Silly me. So college, what does college cost? Well, as of right now, tuition at Cornerstone for yearly, so that's tuition actually, and room and board and meal plan costs about 34,500 a year. So that's what Dave would like to save up. He can invest money at 5%, right? So simple interest rate at 5%. We'll use simple interest computations in this example. And then with a recently born child, we're going to assume that we have those 18 years of growth for the money. So we want to determine how much David has to invest now in order to have that 34,500 available for his child in 18 years. And so we're actually working with this idea of what we call a future value. What is the future value of whatever we invest? Well, future value, often denoted as FV, is the principal that we invest now plus whatever interest that we earn on that investment. Let's see here. So I can say that future value is equal to P plus, but I is computed as principal times rate times time. So I can pull off that common factor of P and write the future value as 1 plus RT. So that just gives us a way of saying how can I relate what I want to have in the future to what I currently have, the interest rate, and the time that I can invest. Okay. All right. So I know that I want a future value of $34,500. I know the interest rate is 5%, so that's 0.05, 5% as a decimal. And then I'm investing, or David is investing for 18 years, and years is the appropriate time measurement, so that's good. So we have future value, rate, and time, leaving us just with the principal that we don't know, which is precisely what the question is asking for. So that is wonderful. That allows me to write the equation 34,500. The future value desired is equal to P times 1 plus 0.05 times the 18. P times 1 plus RT. Okay. With that, I'm actually going to leave this as 0.05 times 18. I like to leave my computations till the end. You might choose to do differently, but I would encourage you to not do any rounding. So be cautious about that. Since we have P times a number, I can simply divide both sides by that number. So I have 34,500 divided by 1 plus 0.05 times 18 is equal to P. We can punch that into our calculators, and what we'll find is a value of 18,157.89474. That decimal may keep going, but this is the value of P. That's our principal that needs to be invested. Now, of course, I can work with 18,157.89, but I can't have 4/10 of a penny. In fact, I can barely get a penny since they're not being minted anymore. So for now, we'll just assume that we can still round to the nearest cent. And really, rounding to the nearest isn't going to guarantee us what we want. If I round this down, like rounding to the nearest would suggest, $18,157.89, I'll actually be just slightly shy of the 34,500. So is that good enough? Probably, because it's not, maybe won't make a ton of difference. But when it comes to later material where we're going to be compounding things, what we'll find is that by rounding down, we actually might be a bit off on our values. So rounding up will ensure that we get the desired amount. Do whatever you think is best. For the most part, read directions carefully to see if it's specified in the problem as to what we need to do. For this problem, I'm simply going to round to the nearest, and we'll call that sufficient. So we'll say that David needs to invest $18,157.89. And that looks good. Excellent work, David.